According to the rule of sample proportions, if both n times p and n times 1 minus p are greater than or equal to 10, then the sampling distribution of p hat can be approximated using a normal distribution. I'm going to use StatKey to construct a few sampling distributions to show you why this is true. For ease of calculation, I'm going to change the population proportion to 0.50. This will make it easier for us to calculate n times p and n times 1 minus p. We'll start with a small sample size. We use n equals 10. When n equals 10, n times p and n times 1 minus p both equal 5. Let's generate a few thousand samples to see what the distribution of sample proportions looks like. Here I've generated 8,000 samples of n equals 10. The mean sample proportion is 0.500, which is equal to our original population proportion of 0.5. The standard error, or the standard deviation of this distribution, is 0.157. With a sample size of 10, we could have 0 heads, 1 head, 2 heads, 3 heads, up to 10. There are 11 different possibilities. Because this is a discrete variable, we can see that there are these big gaps in between the possibilities. In this case, it would not be appropriate to use the normal approximation method because there are large gaps between each of the possible sample proportion values. Let's see what this would look like with a larger n. We'll change n to 200. Again, I'll generate a few thousand samples. With a sample size of n equals 200, I've generated 8,000 samples. The mean sample proportion is 0.499, which is approximately equal to our original population proportion of 0.5. The standard error, or the standard deviation of this distribution, is 0.035. We can see now with a larger sample size, the gaps between each of the possible sample proportions are much smaller. This distribution looks more similar to a normal distribution than did our sampling distribution when n equaled 10. In this case, we could use the normal approximation method. In other words, we could use a normal distribution to approximate this sampling distribution.